Welcome to the deep dive. Today we're looking at something pretty significant, maybe even foundational, happening in the digital identity space. We're talking about the UIID v1 stable release. Now, the developers are calling this the starting gun for Web4, which is, well, that's a bold claim. So our mission today is to really dig into that. We're going to unpack the architecture behind this v1 release, figure out why they're so confident about its stability and security, and we'll break down the new API, not just the technical bits, but what it means for you, the user, in terms of control and how developers can actually integrate this whole thing. It's meant to be the bedrock for this Web4 idea.
Yeah, it's a big step. The digital identity has always been this trade-off, hasn't it? Security versus convenience. And usually, the big companies held all the cards. UIID tries to flip that script. It's fundamentally a decentralized identity protocol, built right on the idea of decentralized identifiers, DIDs. And this is the key thing for you, the listener, to grasp. Your identity isn't just sitting in some company's database anymore. It's on a distributed network, secured. And crucially, you hold the keys. It's about moving away from renting your identity, basically. You actually own it. That's the promise of digital sovereignty here.
Okay, sovereignty. Let's unpack that because it sounds great, but there's a real tension, right? How do you make something super, super secure, like a vault, but also usable for, I don't know, logging into your favorite game or shopping site? Because maximum security usually means it's a pain to use, and flexibility often means, well, less security.
Exactly. That's the core problem they had to solve. And their solution, the core of this V1 architecture, is this really clear separation of identity layers. It sounds simple, but it's quite clever engineering.
A mandated separation?
Yeah, mandated. It's not optional. Sure. They designed two distinct types of identity to handle different jobs, different risks.
Okay, let's start with the foundation then. The core ID. You called it the bedrock earlier. What exactly is that?
The core ID. Think of it as your permanent, unchangeable, sovereign digital self. It's the absolute root, the backbone. And because it's so fundamental, it's designed for maximum security, which means it's hardly ever used directly for everyday stuff. Its main job is for what they call first-party actions.
First-party meaning actions you take directly in your own UIID dashboard.
Precisely. Like managing which apps were even allowed to ask for your data, setting up your security keys, your multi-factor authentication, things only the owner should ever touch. And to keep it rock solid, writing anything to the core ID is incredibly restricted, really limited to non-critical stuff.
Non-critical, like what? Changing the theme color of your dashboard, setting notification preferences, things like that.
Yeah, exactly. Minor configuration data. But even for that, the security is tight.
Why be so strict about, a theme setting? Because any unauthorized write, no matter how small, signals a potential breach. So even for that theme setting, if an app wants to use the core ID's key value store, it needs a specific permission scope. Core.write. And here's the kicker. Asking for core.write automatically mandatorily triggers a multi-factor authentication challenge. Okay. So it's not just asking nicely. The system forces that extra security step. If you, the user, haven't set up 2FA, that request just fails. It fails. Full stop. It's a non-negotiable security gate built right into the API flow. No MFA configured. No core.write possible. It really drives home the philosophy. The core ID is meant to be read when necessary, but almost impossible to write to, preserving its integrity. Okay. So if the core ID is the vault, locked down tight, how do we actually use this identity online day to day? That must be where the alias ID comes in.
Exactly. The alias ID is the practical, flexible part. These are the identities you use out in the wild. Think of them as, well, masks isn't quite right, maybe personas. They're disposable, context-specific identities. So you might have one alias just for work applications, another one for your gaming profile, a separate one for online shopping, maybe a very specific, isolated one for a secure healthcare portal.
And the real benefit there for the user is stopping that creepy data correlation, right? What you buy shouldn't link back to your professional profile or your health info.
Precisely. It enforces data segmentation at the identity level. If one service gets breached, the alias used there only holds data relevant to that service. It can't be easily linked back to your core ID or, crucially, to your activities using other aliases in completely different contexts.
It breaks those data trails.
Yeah.
And it gives you, the user, that ultimate control the kill switch.
It absolutely does. If you lose trust in an app or just decide you're done with a service, you go to your dashboard and just delete that alias. Poof. That action instantly and permanently breaks the connection. The app can no longer use that identity to access anything, and the data it's stored under that alias becomes effectively orphaned from your perspective. It's the right to be forgotten for that specific relationship. And apps can manage these aliases, create them, write data to them, but only if you say so. Right. Through specific permissions like alias.create or alias.write. Yes, always with explicit user consent. An app might request to create an alias to streamline sign-up, for example, but it can't do anything until you, the user, go through the secure authentication flow and click Approve on that specific permission. It keeps you in the driver's seat, even while allowing for smoother interactions between apps. It enables interoperability without sacrificing your control or creating new data silos you can't manage.
Okay, that architecture sounds robust. Which leads us nicely into the stability claims for V1. The announcement used some strong language, promise, guarantee, uncompromising focus on reliability. That suggests more than just good coding practices.
Yeah, they're very confident.
Yep.
And that confidence seems rooted in throwing out the old password model entirely. The core security relies on pure cryptographic proof, making passwordlessness the default. The key technologies here are zero-knowledge proofs, or ZKPs, and WebAuthn.
Okay, let's pause on those. ZKPs. They sound complex. What does that mean in practice when I'm just trying to log in?
It's actually simpler for the user in the end. ZKP means you prove you have the secret key usually tied to your phone or a security key via WebAuthn without the secret key itself ever crossing the network. So instead of sending a password or even a hash of it, your device performs a cryptographic challenge locally. The server just gets a confirmation. Yep, this person has the valid key. It never sees the key.
Right, so the whole concept of stealing password databases just evaporates.
Yeah.
Because there's no central pot of secrets to steal.
Exactly. The attack surface fundamentally changes. You're proving possession, not sharing a secret. And WebAuthn is the standard that makes this work smoothly, with modern hardware fingerprint scanners, Face ID, physical keys. Every interaction, from logging into your main dashboard to approving an app's request for an alias, uses this end-to-end secured passwordless method.
Beyond the crypto, they also talked a lot about operational stability, zero defect tolerance, handling peak loads. How do they back that up for something meant to be global infrastructure?
That comes down to intense testing unit tests, integration tests, massive stress tests. They seem to have built it with a focus on resilience, likely using things like microservices distributed globally. The idea is that the system has to handle huge sudden spikes in usage without faltering, because if the identity system goes down,
Everything that relies on it goes down too. Okay, so they're planning for massive scale from day one.
they have to be. For enterprise use, for regulated industries, you simply cannot have an identity system that's unreliable. So they're claiming high availability, low latency, even under extreme load. That operational guarantee is almost as important as the cryptographic security for real-world adoption. And the final piece of the trust puzzle, governance. They're saying, don't just trust us, verify it yourself. Right, that's the transparency angle. Instead of asking a company for logs, if you suspect something fishy, UIID provides Audit Log Endpoints directly in the API, a P of 1 audit core and a P of 1 audit alias.
So I, as the user, can literally see a detailed record of which app accessed my core ID or a specific alias when it happened and exactly what permission scope it used.
Yes, every single access event is logged, and you have access to that log. It's non-repudiable. This isn't just a nice-to-have. It's essential for compliance in areas like finance or healthcare, where auditing data access is mandatory. The governance isn't just a policy document. It's baked into the system as an immutable log you control access to.
That really does shift the power. You're not just a user, you're the auditor.
Yeah, you have the visibility, and developers know they can integrate this and meet strict regulatory requirements because that auditability is guaranteed.
Okay, let's shift gears to the developers now. The API itself, it's built on OAuth 2.0, which is, well, it's familiar, the industry standard, but they've clearly layered their own security on top.
It's a smart move, actually. Using OAuth 2.0 means developers don't have to learn a completely alien system. They understand the basic flow. But UIID didn't just copy-paste OAuth. They defined a very specific mandatory 4-stage zero-trust authentication flow that every single integrating application must follow. The security isn't optional. It's enforced by the flow itself.
Right. Let's walk through those 4 stages, maybe focusing on why each step matters for security, not just what it is. Okay. Stage 1. App registration. This is setup. The developer registers their app in the UIID dashboard, gets their client and client secret, tells UIID where to send the user back, the redirectory. Crucially, this registration itself is a first-party action. Only the verified developer can do it. Establishes a known entity. Okay. Stage 2 is where the user and the ZKP comes in. Correct. Stage 2. Authorization and ZKP. The app sends you, the user, to UIID's authorization page. Instead of username password, you get that secure ZKP challenge using your WebAuthn device. You prove it's really you. After you're verified, then you see the consent screen. App X wants permission to do Y and Z. You explicitly approve the requested scopes. This stage is all about high-integrity user authentication and informed consent. Okay, verified user, explicit consent. Now, stage 3, the code for token exchange. This seems like a point where things can go wrong in standard OAuth if not done carefully. And UIID locks us down tight. Stage 3, code to token exchange, server-side security. After you approve, UIID sends a temporary one-time use authorization code back to the application's redirects right. Here's the critical zero trust part. The application's backend server must immediately take that code and exchange it for the actual access token and refresh token by making a secure server-to-server POST request to UID. The rule is the client secret, the app's master key, must never be exposed in the browser or a mobile app. It stays locked away on the server. Got it. So even if someone malicious somehow intercepted that temporary code in transit, it's useless without the client secret.
Exactly. It forces developers to use secure back-end practices. This exchange results in a short-lived access token for making API calls right now, and a longer-lived refresh token for maintaining the session.
Which brings us to stage 4, actually using the API.
Right. Stage 4, protected requests and refresh flow. The app uses that short-lived access token in the authorization. Bearer header for all subsequent API calls to UII. Because it expires quickly, if it were somehow leaked, its usefulness is limited.
When it expires, the application uses the securely stored refresh token to silently get a new access token from UIID in the background, using the grant-type refresh token. This means you, the user, stay logged in without having to constantly re-authenticate via ZKP, security plus convenience.
That whole flow sounds really well thought out, locking down each step. But the real user control, the granularity, comes from the permissions themselves.
Yeah.
The scopes, right? It's not just, let this app access my account. Absolutely. Scopes are the heart of delegation. They define exactly what an application is allowed to do, adhering to the principle of least privilege. Can it read basic profile info? Can it read sensitive data? Can it write data? And this is vital for maintaining that separation we talked about between the core ID and the various aliases. An app asks only for what it needs, and you approve only what you're comfortable with.
Let's look at some specific scope examples from the documentation to see how granular this gets. Say, for something like verifying identity for a financial service KYC. Okay, for KYC status, an app would need the core.read.sensitive scope. Notice it specifies core accessing fundamental core ID data and sensitive. Even though it's just reading, the type of data requires a very specific, high-privilege scope, and that scope needs explicit consent, and the access is logged in the audit trail we mentioned every time. Now remember the core.write scope we talked about for changing minor settings on the core ID, the one that triggers mandatory MFA. Exactly. That scope, core.write, represents maybe the highest level of trust you can grant an app regarding your core ID. And because it's so sensitive, the system enforces MFA. If you don't have it set up, authorization fails, period. That enforcement is key. It's not just a suggestion, it's built in. What about protecting data within the aliases? Can we add extra layers there? Yes. Let's say an app wants to read potentially sensitive private data associated with one of your aliases, maybe medical notes in a healthcare alias. It would need the alias.read.private scope. Now, UIID allows you, the user, to optionally protect specific aliases with a PIN. If you've set a PIN on that healthcare alias, when the app requests alias.read.private, the UIID consent screen will prompt you to enter that specific alias PIN. So even after the initial ZKP login, there's another potential check specific to that context.
Right. If you don't enter the correct PIN for that alias, that specific scope request is denied, even if you approve everything else. It gives you tunable friction. You can make accessing data tied to more sensitive aliases require an extra step.
That's really granular control. And if an app wants to show me my own audit logs within its interface, it needs another specific scope for that, audit.read. This lets the application fetch and display the audit logs related to your core ID and the aliases it's authorized for. So even accessing the transparency logs requires explicit permission. Okay, so the framework is secure, the permissions are granular. What about making life easier for developers trying to build on this? Stability, error handling, the practical stuff. They seem very focused on good API citizenship. Standard HTTP error codes are used. 400 if the developer sends a BAT request, 401 for an invalid token, 403 if the token is valid but lacks the needed scope for an action. Makes debugging predictable. And preventing overload. A popular app could hammer the system.
That's where rate limiting comes in, signaled by a 429 too many requests error. UID limits requests based on both the IP address and the specific access token being used. This prevents a single busy app even one distributed across many servers, from overwhelming the core identity service.
And if a developer does get rate limited,
They must respect the retry after header in the response. It tells them exactly how long to wait before trying again. No hammering allowed. It's about maintaining stability for everyone using the platform.
the docs also mention something specific about how lists of data are handled, like getting all my aliases. They use cursor-based pagination. Why is that important?
Yeah, that's a technical detail, but crucial for scale. Old-style pagination, like give me page 3, performs terribly on huge, constantly changing data sets. Cursor-based pagination uses a pointer to the last item you received, so you just say, give me the next batch after this pointer. It's much, much more efficient and reliable, especially when dealing with potentially millions or billions of identity records globally. It backs up their claims of being able to scale.
Right, that efficiency underpins the whole production-ready infrastructure claim.
It really does. It shows they've thought about the practicalities of running this at internet scale. It moves UID from just a cool idea to something potentially usable as real infrastructure.
Okay, so all this tech, the core alias splits, ZKP, MFA enforcement, the robust API, it all builds towards this Web4 vision, as they call it. How does UID v1 actually enable that shift away from the current Web2 model?
Well, Web 2 is defined by data silos, right? Your Google data is here, your Facebook data is there, your bank data is somewhere else. They don't talk to each other easily, and the platform owns the relationship, owns the data context. UID aims to break that by making identity and authenticated data portable and user-controlled through this interoperable alias and OAuth structure.
Can you give a practical example? Like, how would this work differently if I switched, say, doctors or banks?
Okay, perfect example. Healthcare is famously fragmented. Let's say Clinic A has verified your identity and holds some authenticated health records under an alias you approved. Now you move to Clinic B, which also integrates with UID. Instead of starting from scratch, Clinic B requests access. You authenticate via ZKP, and on the consent screen, you might grant Clinic B permission, via specific scopes, to read your verified vaccination record, which was attested to by Clinic A and linked to your core ID. The data, or at least the verified claim about the data, can move securely between Clinic A's context and Clinic B's context using standardized tokens, without either clinic owning your core identity and without needing a complex, insecure direct integration between the clinics themselves.
So my verified identity credentials become portable, like a digital passport that I control, letting different services access specific visas or pieces of information as I allow. That's a great analogy. The Web4 principles enabled here are 1. True user sovereignty. You own the core ID, you control the aliases, you have the kill switch. 2. Interoperability by default standardized tokens, and the alias model let data flow securely, breaking silos. 3. Trust via cryptography ZKP WebAuthn replaced the need for blind trust in central platforms. And crucially, they made it relatively simple for developers to actually use this powerful system.
That's key for adoption. Developers just need to implement that standard OAuth flow. They provide SDKs for common languages, PHP, JavaScript, Python, so developers can leverage this advanced decentralized identity tech without becoming cryptography experts themselves. UID handles the complexity, essentially offering itself as that secure, stable digital passport so developers can focus on building their actual application features.
Okay, so summing up this V1 release, it feels like they've delivered a really solid cryptographically sound foundation. They tackled that core security versus flexibility problem with the core alias split. And they've made it practical and trustworthy with the rigorous OAuth flow, the granular scopes, mandatory MFA where needed, and that crucial transparency through audit logs.
Yeah, I think V1 marks the point where decentralized identity moves from theory to practice. It's offering the stability guarantees, the scaling mechanisms like cursor pagination, and the verifiable governance that real-world applications, especially regulated ones, actually need. It makes the Web4 vision feel, well, achievable. So for our final thought today, something for you, the listener, to chew on regarding where this might lead, especially in professional or regulated spaces, consider the deliberate design choices in the API itself. You have these public utility endpoints, like a PO1 core regenerate. It just creates a UID string format, no authentication needed, doesn't create a user. It's just a tool. Then at the other extreme, you have endpoints like the KYC status check, needing the highly restricted core.read.sensitive scope, requiring full ZKP auth, consent, and leaving an indelible audit trail. The system knows the difference between public information and highly sensitive verified identity attributes. So the question becomes, what kind of complex global regulated processes, think international trade finance, cross-border professional licensing, secure supply chain verification, become possible when you have a stable, scalable platform that can cryptographically guarantee identity, enforce fine-grained access, provide immutable proof of every interaction? What can be built on that foundation of verifiable trust?
A fascinating question indeed, a potential paradigm shift. Thanks for exploring that with us today. That's all for this deep dive. We'll catch you next time.